Now we are on our sets. So what are sets? A collection of unordered and unindexed data items, or we can call them elements, written in curly brackets. These are called the sets. This is the traditional definition that all the mathematics, logic and the computer science engineers used to learn in their textbooks. So, but we are not the simple ones, right? We are the curious ones. So we have a different kind of the understanding and the definition of our own in this case. So let's see what are the sets. Set are the bundles, let's say the bundles of similar elements. What do we mean with this? Let's see what do we mean with this in the example of the coding itself. Let's see. This set, we have written this set is equals to, we used the curly brackets and then we have used the strings apple, blueberry and mango. As you can see, these three are the strings. And to the most important thing, these all three are the fruits. So we actually create and try to put the same or similar data items in the set. Now when we command it to print this set, the output will show something like this: mango, apple, blueberry. As you can see, the order in which we are going to get these outputs are not guaranteed when we use the set, because set gives us unordered and unindexed data items. Let's understand this in a better way on our board. So first we have to wake up our curious engineer. Let's make it a beautiful girl. Well, sorry for my drawing, but I have tried my best. Let's give her the super specs. Now this is our super girl. She will going to teach us that what is the meaning of the set. Now let's get set. Okay, so in the curly braces, when we use the number like 1, 2, 3, so this is the set. Okay, so what are the differences? Let's understand the difference with this SCHOOL, school. Now let's write this English spelling of the school in the set. So SCHOL. So as you can see, the two O's got vanished and we only have the one. Why so? Because this is the set. And you might say we are losing the data, but that is our advantage. We are letting it as the advantage. What kind of advantage it gives us? Can you imagine that if I write it 2 times and it is writing just 1, what can be the possible advantage for that? Well, let me tell you. Let's imagine that you have saved 2 folders or 2 files, and you are trying to save the file. Like let's say this is also a file, this is also a file, and you are trying to save these files, and you are trying to save this file with the name A, and it got saved. So it's saved in the memory. At the very same location, if I try to save it with the letter A itself, it will not accept it. The machine will not going to accept the same name, or sometimes by default it will going to add A.1 or something like that, but not the A. A is not acceptable. Why so? Why our machine not allows that? Because it considers the logic of set, in which the repetition is not allowed. Like in our case, the 2 O's, but in the set we only have the 1 O. So still, what is the advantage of that? I do not see any kind of the advantage in that. Well, let me tell you. Just imagine, my friend, that if you command your machine once you saved it. Let's say that somehow we figured out a way and at the very same location both the files with the name A saved. Inside of them there can be completely different information, but let's say its name is saved very same with A. Now as an operator, when anyone types on their keyboard, well, it seems like piano but let it be like our computer, okay? So when we type it and call the file A, let's say you have opened the run control O open or just anything, anyway you are trying to open the file A. What will going to happen? Your machine, the CPU, the brain of the computer, well, you can call it GPU, pretty much the same thing. Now what will it get? It gets a question or a task, let's say, task is the better word. It get a task of getting a file A and show it as the output. Now our machine is going to get confused, because when it searched in its register or directory or whatever you're going to call it, it's present in the memory at the very same location, the two files named as A. Now the machine is confused because it do not know that which file is actually called up, because it can just read the names and it is not allowed to read what's inside unless it is opened, and to open it, it has to fetch it to the main memory or to the RAM, and to fetch it, it must have different names. It is more like if you are having kids in your home and you have two kids, let's say, and you name both of them same. Let's say you name both of them as what should I say, Lisa. You named both of them Lisa. Now when you say Lisa, oh my baby, please come, what will going to happen? Both the Lisa kids are going to think they are being called, but which one you are calling creates a confusion. That same confusion happens with the CPU or the GPU or the brain of the computer. They get confused, and what it is called as, well, we all have heard this word, corrupt file. It is going to get corrupted. The file not open, the file gets corrupted. It is like this one. So actually it's like this one, it's get corrupted. So you have to do something that it should not corrupt. That's why by default it is sometimes added, actually in most of the recent day computers add this thing, that if you even if you try at the very same location with the same name, either it will not allow you, or simply it will add something like A.1. It is going to add that 1, 2 and the sequence of the number so that it can distinguish, and later the file do not get corrupt. So now you might got the clear idea that how mighty the set theory is. If it is not set theory, how much confusing it actually gets. Now let's see the more things about the set theory. Actually not the set theory, about our course. Okay, you can't use the index to find the data items. You cannot get the index. Like you can check, in our case we here printed apple in this set. This set, as we have seen earlier, is here. This is this here, and in is a function we are checking. It is to check that if the apple, the element apple is the element, is present in this set or not. This is just the name, this set. Okay, so this set or not. So our output in this case is true, which is binary. So the answer here we get as true, because apple is indeed present in this set. As we have seen, the apple, blueberry and mango, all three are present. But if I have asked it, instead of apple, if I have asked it to check if any elephant, let's say if any elephant in this set, so that true will be false, means it's not present. That's simple. But at which number, like on indexing we have the numbers, like apple was in the first place, blueberry was in second place, mango was in third place. So on which place it is, we cannot find that. The order does not matter in the set, right? That's why we are able to shuffle the folders up, down, and we can use that on our desktop so many times. Like in my desktop itself, my laptop actually, in my laptop itself, the first folder on the desktop is not about the admin or this PC or that kind of thing. It's just a simple folder, and after that it's a recycle bin, and after that it's my PC. So this way I have organized it. I can shuffle it because in the set it does not matter. Like in this case, let me take you here that we have just studied. If I write something like SCHOL, it is completely equal to something if I write CSHLO. These two are equal. Why? Because all the element which is present in the first one is actually equal to the second one. All the elements are present, so it is true. So in short, it does not matter which way you are working or what comes first. It does not matter. So that is the priority order, which is actually not even matter. That's why I have kept the output different here, like mango, apple and blueberry. If you have typed this in the open compiler and the apple, blueberry and mango comes as it is, don't get worried. To check, again run the output. Just let the input be same and again run the output. When you run the output, when you type this set is equals to bracket apple, blueberry, mango in the very same sequence and print this set and takes the output multiple times, all the time you are able to see the shuffling. All the time you are guaranteed to get the three elements, but their order is not guaranteed. So that's what I want to teach you in the set. Now in the next one we are going to see the set operations, but that's for the next video. Till that time, stay curious and keep on learning.